Alright, so welcome to my channel. If you're new to this channel, don't forget to subscribe and hit the notification bell for you to be updated for all the incoming videos that I want to share here in this channel. Alright, so right now our focus would be the square of binomials. So here, the square binomial square the first term of the given binomial plus twice the product of the first and second term plus the square of the last term. So take note, you square the first term twice the product plus twice the product of the first term and the second term plus the square of the last term. And this product is called the perfect square trinomial. Okay, so we have here the quantity of x plus y raised to the power of 2, or open and close parenthesis x plus y squared or raised to the power of 2. So it becomes x squared plus 2xy plus y squared. So same way if the operation is minus, so the quantity of x minus y raised to the power of 2, so the product would be, or the result would be, x squared minus 2xy plus y squared. So here we have here an example, the quantity of x plus 3 raised to the power of 2. So let x is equal to x and y is equal to 3. So using x plus y, so raised to the power of 2, so is equals to x squared plus 2xy plus y squared. Okay, so then the quantity of x plus 2 raised to the power of 2 is equal to x squared plus 2 times x times 3 plus 3 squared. Remember that here in this expression, okay, we are now what do you call this one, we are now proving, okay, the square of binomials. So in this case, so square the first term, then the product of the product of the first and the second, and finally the square of the last term. So here, this is here in this uh, expression. Now the quantity of x plus 3 raised to the power of 2 is equal to x squared plus 6x plus 9. So as you can see, uh, this is the final result. Okay, x squared plus 6x plus 9. The square of the first term, and then twice the product of the first and the last, and finally the square of the last term. So same with if the operation is minus. Okay, so now we go with we go with the example. Okay, so give the perfect square trinomial. Okay, so okay, so here the quantity of m plus 1 square. So square the first term, m square, twice the first and the last. So 2 times m is 2m times 1 is 2m. So positive 2m. So twice of the first and the last term. The next, finally, square the last term plus what is 1 square. So 1 square is 1 times 1, so the answer is 1. So this is the result of the product. M square plus 2m plus 1. What about the other? So again, same. Square the first square the first term, m square, then 2 times m, 2m, times negative 1, so negative 2m. Then the square of the last term, negative 1 square, so the answer is positive 1. Negative 1 times negative 1, the answer is positive 1. That's why we have positive 1 here. Next, number 3. So square root of the first term, m squared, then 2 times m, 2m times negative 4, negative 8m. Then square of the last term, negative 4 square plus 16. Next, the variable is x, not m. So next, square of the first term, x squared, twice the first and the last, the plus 10x. Square of the last term, 5 square plus 25. Next, this is plus. Next, z is the variable. Square the first term, z squared, twice the product of the first and the last. So 12 plus 12z. Then square the last term plus 36. Okay, so next, k square the first term, k squared, twice the product of the first and the last, negative 8k, square the last term, positive 16. Okay, so can you do it for me? Okay, can you do the last problem, number 7? Okay, so comment down below the answer, and hope you learned a lot from this lesson. Okay, square of binomials. Again, so square of binomials. So to do that, square the first term in the given binomial plus twice the product of the first and the last term plus 6, then or finally square the last term. So this things that you are doing, or this product, is called the perfect square trinomial. So take note, guys, that we have two type of this perfect square trinomial. The one that is in addition operation, and also the other is in subtraction operation. Okay, so thank you, and don't forget to subscribe for more videos like this. Okay, so God bless.